So we're starting chapter 3. Chapter 3 is inequalities. A very large portion of chapter 3 is just like what you did in chapter 2. Most of what you do in chapter 3 is just like what we were doing in chapter 2 with a few adjustments here and there. Okay? So, solution of an inequality is any number that makes an inequality true. Okay? Our answers are not going to be singular. We do not get x equals with an inequality. We get a range of answers. There's more than one numeric possibility. We get a range of answers. That's one of the big differences about inequalities, is that it's not just one number that our answers are. Our answers are technically an infinite number of possibilities. Okay, there's a range. We from here up or from here down, things along those lines. So, some examples. We have less than. Our symbol for less than. X is less than, or 2 is less than. You'll always read it from left to right. I'm trying to remember. Nope. So for example, if I have X is less than 3, it's everything that is smaller than 3. When you are graphing, do not make the assumption that the arrow points the direction of the inequality. Depends upon which side the variable's on. Okay. We have greater than, pointing in the opposite direction. Okay. Greater than symbol. For example, if I have X is greater than 1, that means I have everything larger than 1. Is X actually 1? No, X is everything larger than 1. Does that mean we start at 2? No. Because yes, 2 is larger than 1, but isn't 1.5 larger than 1? Isn't 1.25 larger than 1? You don't start at the next whole number up. You start just larger than that. 1.00001 is larger than 1. Okay. Less than or equal to. Slightly different. Everything is less than that number or equal to that number. And our symbol is slightly different. Has a little extra line on it, which means that that number is included. For example, if I have X is less than or equal to 2, that means it can be 2 and everything's smaller. So X can be 2. Because it's or equal to. So everything's smaller than 2, and 2 itself will also work. And then we have greater than or equal to, which means everything greater than or any number equal to that. So for example, if I have X is greater than or equal to -1, can X be -1? If everything's greater than or equal to -1, can X be -1? Yeah, because it's or equal to, so it's allowed to be that number. Okay. Now, when you're graphing them, be very careful. Okay. You'll notice some of them, the numbers are included, some of them are not. The ones where the numbers are not included, I have an open circle because that number is not included. An open circle means that it goes right up to that number, but it's not actually that number itself. It gets so close that we can't draw something that close. So what we do is just put a circle around it and say, hey, it's not this number, but man, it's so close that we physically cannot draw on the number line that close to where it's not. So we're just going to put a little circle in there and say it's not this, but it's really right up next to it. If it's or equal to, they are filled in because it can be those numbers. How do you remember the difference? I got a little extra line. I use a little extra lead. Okay. I got the extra line as or equal to. That means I fill in the hole. Okay. Now, I want to pause this for a minute, and I want to share a story with you. Okay. In math, we use symbols for everything because mathematicians are lazy. Before we came up with all these symbols, now some of these symbols we know where they come from, some of them we don't. Okay? Some of these things we do know where they come from, some of them they don't. There are some things that we will do as mathematicians that is absolutely incredible how silly they are. For example, we use this instead of writing the word therefore, because we don't want to write a 8-letter word. So we'd rather draw 3 little circles instead of saying the word therefore. Okay, it can get really kind of silly at some point. Now, like I said, we know where some of them come from. We don't know where some of them come from. We do know where these come from. People weren't always using the inequality symbols. They were having to write it out in words every single time. Every single time they would have to write it out in words. That gets a little tedious. So we decided to come up with something new. Now, the story behind this is that this takes place right about the time the Europeans were coming over to North America, discovering the New World, as you might say. And they loved to come over. Scientists were loving coming over to North America because they were seeing things that they'd never seen before. Think about never ever seeing a raccoon. Ever. Even hearing about a raccoon. Okay, those are funny looking animals. Stripes on their tail. They look like they're burglars because they got a little mask over their eyes. Okay, or a skunk. They don't have skunks in Europe. Could you imagine seeing a skunk for the first time? Could you imagine, oh, look at that, isn't that cool? Oh my Lord. Could you imagine that? Okay, so there's this English mathematician, and I forget his name off the top of my head. He had a friend who was a scientist who was going over to America, and he says, hey, dude, come with me. Got to check this place out. Come with me. You got to check it out. Fine. Yeah, I'll go with you. And it's not like, you know, it's a car drive that's going to take them a few hours. To get there, it takes several months by ship at that time. And they get there, and this mathematician did what a lot of scientists would do on a trip like this, is they took notes. One of the things that fascinated this mathematician were tattoos that the Native Americans had. Now, it's not like they had never seen tattoos before. Tattoos have been around for centuries. Okay? It's not like you've never seen them before, but these were a little different. The Native Americans were wearing tattoos for particular reasons, cultural reasons. They had stuff behind them. And so he would, anytime he saw a tattoo, he would sketch in the sketchbook a picture of the tattoo, a picture of the tattoo, a picture of the tattoo. There was one tattoo that he was so enamored with that he said, hey, you know, when he got home, he said, you know what, I got to figure out some way to get this tattoo incorporated into the math that I'm doing. And that's where these symbols came from, because the tattoo on the guy's shoulder, and I've seen a copy of the sketch in the mathematician's sketchbook, and the tattoo on the back of his shoulder looked like that. And so he said, I got to use that. And that's where our symbols for inequalities came from. Some guy's tattoo on his shoulder. Okay. When I read that years ago, that is cool. That's a really cool. Because you don't know where some things come from. And some things, they come from weird places. That's a weird place to have it come from. It is kind of cool. So I thought I'd share that with you. Okay, so let's start doing these. Okay. So when I do inequalities, I have, when I'm writing them out, I concern myself with a few things. First thing is, what number am I talking about? So in this first one here, what number am I talking about? -7. -7 is what I'm dealing with. So I got -7. Okay. And then I'm dealing with a variable, and it tells me in this case my variable x. Okay. And what's the relationship to them? Okay. X is less than or equal to. That's my relationship between the two variables. So x is x smaller or larger than -7? X is less than, right? So x is smaller. So that means that if I have -7, x is going to be smaller than -7. It's going to be smaller than -7. X is less than. Or equal to. So what do I need to add for the or equal to? The little line underneath. Okay. That's it. Now, if you're not sure which direction the arrow points, always remember the alligator eats the bigger thing. Alligators are lazy. Alligators don't like to do a lot of stuff. They don't like to go around doing a lot of hunting. They like to eat the biggest thing they can freaking eat, so they don't have to eat again for a long time. They don't have to, so they can lay around. That's what they like to do. So the alligator eats the bigger thing. What's bigger? The -7 is bigger. The x is smaller. Okay. It points to the smaller one. The open-ended is to the big one. Okay. So the next one, what number am I concerned with? 100. Okay. So I've got 100. And then I have my variable m. What's bigger, the m or the 100? The 100's bigger because m is less than 100. Do I need the little line underneath or not? No, because it's less than. It's not or equal to. The or equal to tells me I need the little line because it can be that number. Okay. The next one's a little tricky. I have 6 less than the number k is less than 13. This one's a tricky one. Break it down into parts. Okay. 6 less than the number k is, got to use your English skills on this one. Object, verb. Okay? So this is less than 13. So I have this object is less than that object. Okay? So I have 6 less than the number k. How do I write 6 less than the number k? We did this a long time ago. Okay. When I have less than a number, that means I'm doing what? Subtracting, right? So how do I write that?
6 less than 13.
K minus 6. Because I start with k and I take 6 away from that. If I have $6 less than you, you take what you have and take 6 away to get what I have. So I start with k minus 6. That's what that part there is. 6 less than the number k is less than 13. So I have that. I'm comparing it with 13. And what's smaller? The k minus 6 is smaller than the 13. Less than 13. Questions? Okay. Identifying solutions by evaluating. This one actually isn't too bad. Remember, there's more than one solution. When you have an equal sign, there's only one thing that'll work for the equal sign. If I have an inequality, I have lots of possibilities. All 3 of those numbers, -3, 5, or -1, they might all work in that original problem. None of them might work. I don't know. You got to find out. So, how do I find out? I take this and I plug it into there. I put it in for x. I take x, replace it with -3. So that means I have 2 times -3 plus 1 greater than -3. And I simplify and see if it's true or not. I'm not trying to solve. I'm trying to simplify. So I'm only working this side of the problem to see what I get. So 2 times -3 is what? -6. So I have -6 plus 1 is greater than -3. -6 plus 1 is Actually, it's not. What is negative 6 plus 1? Negative 5. So I have negative 5 greater than negative 3. Is negative 5 larger than negative 3? No, it's not. So is this true? No, this would be false. Doesn't work. It's false. It's no bueno. Do the same thing on the next one. I take 5 and I plug it into there. 2 times 5 plus 1 greater than negative 3. 2 times 5 is 10. 10 plus 1 greater than negative 3. What's 10 plus 1? 11 greater than negative 3. Is 11 larger than negative 3? Yes. So this one would be true. What about the last one? Two times negative 1 plus 1 is greater than negative 3. 2 times negative 1, that should be easy. Negative 2 plus 1 is greater than negative 3. What is negative 2 plus 1? Negative 1. So I get negative 1 is greater than negative 3. Is negative 1 larger than negative 3? Yes, it is. Good. So this is also true. Now, the second part we have down there in problem 2, how is the solution related to the equation of 2x plus 1 is equal to negative 3, related to the solutions? And we'll be doing this later. Solving this gives us our answer, x is greater than or x is less than something. How you solve that is how you solve this. Gives us our same solution. Okay, it gives us our starting point. Graphing an inequality. Okay. Here's what I do. What number am I concerned with? Negative 3. So I find negative 3 on the number line, and then I have to put a dot on that 3. Am I going to have an open circle or closed circle? It's going to be open. If I have less than or greater than, it's open. If I have or equal to, it's closed. This one does not have an or equal to, so it's open circle on negative 3. That's your first step. Put a dot on that number, whether it's open or closed. You got to decide, is it open or closed? Put it on that number. Then I want x is less than that. So I want everything smaller. X is smaller than negative 3. When I go smaller, I go to the left. When I go larger, I go to the right. I want everything smaller. That's everything smaller than negative 3. The open circle tells me it's not negative 3, but it's right up next to negative 3. So on the next one, open or closed? Closed. It's or equal to, so it's a solid dot. Then the next line, get a solid dot. On what number? 2. So I put a dot on 2. Now, how many students say that the arrow should be pointing to the left? How many of you say the arrow should be pointing to the left? How many of you say the arrow should be pointing to the right? Okay. Are you going by which direction this is pointing? Because that's not what it should be. 2 is larger than x. If 2 is larger than x, what does that mean x is in comparison to 2? X is smaller than 2. If 2 is bigger than x, then x has to be smaller than 2. You don't go by which direction the inequality is pointing. If variable's on the other side, it switches everything out. So what I want to do is, what's smaller? X is smaller than 2 because x is on the smaller side. So I want everything smaller than 2. Okay? You've got to be careful about that. It doesn't automatically go the direction the inequality is pointing. You look at the variable. Is the variable smaller or larger than that number?
You can flip it too. If you put the X on the other side because you like that, you can flip the variable trade sides, but this guy has to flip.
Yeah, the inequality, if you flip the sides, you have to flip the inequality to go with it. Okay. These actually aren't too bad here. Once again, what number in the first one I have there, what number am I concerned with? -1. So I have -1 and I have X. Is X larger or smaller than -1? Larger. I have my arrow going to the larger side. So X is greater than -1. Is it or equal to or not? It is or equal to. I have a filled in dot. Means I have an extra little line. Get the variable, get your number, and then you have to decide the relationship between them. So in the next one, I have X, and then what number do I have? 4. Dots on 4. Is X smaller than or larger than 4? X is smaller than. X is less than 4. Is it or equal to? No, I have an open dot. I don't have the extra line. Same thing on this one. I have X, and I have -2. Is X larger or smaller? X is larger because it's everything on the right. So X is greater than -2. Is it or equal to? Do I have the little line? No. Open dot, no line. Piece of cake day. Good Monday. Writing real world inequalities. So you gotta look at the sign and you gotta write an equation that I'm dealing with. So I have trail rides starting at, and it's a little hard to read down on your paper, starting at 1999. So what number am I concerned with? 1999. Should do it in purple, but I don't have a purple pen. 1999. I guess there's only 2 of us in this room that are old enough to get that joke. Okay, and then I have X, and I have 1999. Starting at 1999, so how much money am I going to spend? Am I going to spend more or less? I'm going to spend more because that's where it starts. That's the minimum payment I'm going to have. So X has to be bigger than that. Can X be 1999? Yeah, because it's starting at 1999. So it can include 1999. If it's just me, I'm paying 1999. If it's me and a friend, it's going to be more than that. So it can be 1999, so it is or equal to. What kind of a sign is that one?
A stop sign.
I hope you don't have
So
your license.
I'm concerned.
It's a speed limit sign. Actually, is this technically a speed limit sign? What color is the sign? It's yellow, which means it's a caution sign. It's like the kind you see going around a corner. So it's a recommended speed for that particular place. The speed limit is still the speed limit, but they recommend, hey, this is what you ought to go around this corner as. That's what they have. That's what the signs are.
Drive around the corner and stop.
You know, and it usually they're there because the corner's either a little sharper than you might think, or there's one that I go through every morning where there's an intersection right at the corner. And if you go too fast, there's people coming and going that it's not pretty. Okay. So, is this the most or least I could drive? It's the most I can drive. So my speed, is it going to be less than 8 or more than 8? Is it supposed to be less than or more than? It's supposed to be less than. Can I go 8 miles an hour? Yeah, it's less than or equal to. A speed limit is considered to be the top end. You're not supposed to go more than that. Okay? Doesn't mean you can't. Just if you do, you have no grounds to complain when you get caught. My feelings, don't do the crime if you can't do the time. Don't speed if you don't want to take it. You want a ticket, you take your chances. You speed, you take your chances.